thank you for your patience, everyone, and glad you've all come here on a Friday afternoon. As you can see on the screen above you, Dr. Richard Roberts here today. His special talk for us is about spreading peace through science and commerce in developing countries. I'd like to just give you a little bit of background on Dr. Roberts. He's a Nobel laureate, of course, for medicine and research director of New England Biolabs in the States. He was originally educated in England, and when I read further details, he actually was at Bath, and as you know, we're the study centre of Bath University here, so there's good memories. You probably know Jeff Thompson and Mary Hayden over there as well. He then attended the University of Sheffield, where he obtained his bachelor's degree in chemistry, and then did a doctorate in organic chemistry in 1968. His postdoctoral research was carried out in Harvard, where he studied the tRNAs that are involved in the biosynthesis of bacterial cell walls. From 1972 through to 1992, he worked at Cold Springs Harvard Laboratory, reaching the position of Assistant Director for Research. He began work then on the newly discovered type 2 restriction enzymes in 1972, and the next few years more than 100 such enzymes were discovered. So he's had a very, very busy background there. Dr. Roberts' current interest focuses on the identification of restriction enzymes and methylome genes with the gene bank database and the development of rapid methods to assay their function. Quite a complex and detailed background of research history. My background is also in chemistry and biochemistry, so very interesting to hear the points that you're talking. So I'd like to welcome Dr. Richard Roberts here today, and a very interesting talk on peace, and thank the Peace Foundation again for assisting us with this wonderful array of guest speakers that we're having. Thank you, Uday.
Well, thank you. One thing perhaps I should begin with is to tell you that the reason I got interested in science was because when I was a kid, actually a good deal younger than most of you. Can I walk around, please? Okay. When I was a kid, probably 9 years old as most of you, the thing I really liked was to make fireworks. I was really into chemistry and anything that would make a bang, anything that would go up in the sky. I thought that was terrific. Unfortunately, one of the things that's happened in the meantime, at least in the US and England, and I suspect probably here too, is that it's now very difficult to get all of these chemicals that you need to make fireworks, because they're absolutely convinced that anyone who does so is just going to blow themselves up and cause all sorts of trouble. Well, of course, I have to admit, a friend or two of mine did lose a finger here and there. On the whole, I think it was very good training. And I really got interested in science because I suspect that, like many of you, I had a great curiosity. I wanted to know how things worked around me. I wanted to do things and to do them with my own hands. And of course, chemistry is one of the things in which you can do that. And then I was fortunate enough, as I got older, to actually end up in a situation where I could continue to do science, but not by going out and actually paying somebody else so that I could get all of the elements I needed and all of the chemicals I needed, but they actually paid me to do it. So I'm now in this wonderful position of doing science, which I love, and getting paid to do it all the time. And science, I would argue, is one of the very good endeavors, one of the very nice things that one can do as an adult, because it has something associated with it that is inherently peaceful, a very nice activity to do. And let me try and expand on that a little bit before we enter into some discussion. I'll probably say a few things that you may not agree with, and we can talk about that later on. So one of the things about science is that no matter where you do it, whether you do it in Thailand, India, Russia, the US, England, Australia, no matter where, we all do our science following essentially the same set of rules and using the same set of axioms upon which we base everything we do. So if I go traveling around and I talk to a scientist at a university here in Bangkok, we have a common language. We talk about the same sorts of things. If we have a disagreement about something, we're able to solve them using the same kind of language, the same kind of tools, because we have science as our background. And in this sense, I think one learns a great deal about what it is to enter into a dialogue with other people, to get to know other people, and to be able to behave in what I would like to think is a really civilized and peaceful manner. Because we don't need violence and we don't need to resort to extreme measures in order to solve problems. So in this sense, I'm of the firm belief that science is essentially a very peaceful activity. It teaches you a lot of things that will be useful for the future. It teaches you about solving problems, how to solve problems, teaches you how to think about problems. And in many senses, it's a great shame that more politicians are not scientists. Unfortunately, the few examples we've had where scientists have become politicians, they tended to throw away their science and forget about it. Margaret Thatcher, who actually used to be a chemist, was one of the politicians who I think did not take with her the scientific training. But in many ways, I think scientific training and practice of science is a very good thing. It would be good if more politicians arose from the ranks of scientists. Now, one of the other things that is rather good as a result of doing science is that you quickly learn that no matter what kind of science you're doing, whether it's very basic science, which is what I do all the time, or whether it's more applied science, that there are always commercial prospects that come out of it. If you think about what's happened within the world today, the kinds of things that you all take for granted, computers, telephones, television, all of these things have come because in the past someone had been doing some scientific, in this case basic physics research. Think about the detergents that you use when you wash your clothes, the cosmetics that some of you girls probably like to apply. Many of these things have all come from early exploration, early discoveries that have been made in chemistry. Many of the jewels that you like to wear have come as a result of a direct interest in chemistry. And of course, in my own field, biology, there are many, many things that have arisen. Drugs. At one point, the drugs were mainly coming from the chemists, simple antibiotics, simple compounds that were good to help people. But now, more recently, there have been many biological developments, many more complicated things that have become drugs that have come from direct knowledge of biology. And of course, one now can explore the human genes. We can find out what genetic defects may be, what good genes may be present. Lots and lots of stuff that is coming out of this thing that we call the Human Genome Project, and that's maybe something that we could talk about later on if you want to. So out of all of this science has come a great deal of commerce. And on the whole, commerce too is a very peaceful activity. Business does well when there's not war. If you've got a lot of war, a lot of trouble going on, if you have gang fighting, street violence where you have to shutter your store every night, that isn't a good thing. And so on the whole, commerce, which of course we hope will lead to prosperity of people, is something that is again inherently a very peaceful kind of activity. And so here are two things that I've been fortunate enough to be involved in, where I work now as a small company, even though that company is mainly doing research. Sort of half the people in the company are doing research, half the people are making the money to pay for us to do research. I've been fortunate in being a part of a very peaceful operation. Let me just tell you a little bit about this company, because they're really very unusual. The company was started by an academic, a man who'd been a professor at Harvard, and he was in one of the departments where they just don't give tenure, so that after a few years you have to leave and go and get a job somewhere else. And they did this as a matter of principle. Now he thought this was very unfair, didn't like the system, and so he said he was going to get out of the academic system. He was going to start a company and have the company make money and use that money to pay for research. And so that's what he's done. We now have a company of a little over 200 people. Half of the people are making money and the other half is spending it doing research. And a lot of that research is really very, very basic research. So for instance, one of the programs that we have going is aimed at a third world disease, a disease called filariasis. Some of you may know it. You may have heard of elephantiasis. It's caused by a parasitic worm. It's endemic among really a lot of cetaceans. It's a disease that was one of the top diseases on the World Health list of nasty things to be worried about when we got started 20 years ago. But it was a disease that almost no one was funding. No one was putting any money into this particular disease. We have funded it through the company to the tune of about $2 million a year over the course of the last 20 years. And recently we've actually ended up making some quite interesting breakthroughs in this disease. And we hope that in the not too distant future there will actually be some therapies that will come as a result of the work that we've done. We've probably spent more money as a company on this particular disease than the whole of the NIH, that's the National Institutes of Health in the US, because in general, the developing world doesn't care terribly much. The developed world, rather, doesn't care terribly much about the diseases that affect developing countries. But again, this is all because of this one company. The guy who runs it is actually much more interested in science and using modern techniques to solve biological problems than he is in just simply making money. I think we have some very interesting sound effects here, almost like Star Wars. So I think what I'm trying to show is that here, by doing science, by doing a little bit of commerce, it really is possible to make quite a difference in this world and to promote peace in ways that you may not have immediately thought of as being inherently peaceful activities. There are really lots and lots of things that one can do to promote peace, and you can do it on a small scale. We actually help fund a number of labs in developing countries. We have labs in Cameroon, we have labs in Indonesia, we have labs in China that we're supporting, actually looking for new products that we can sell through our company, and then as we sell them, we give royalties back to the labs that have provided these things in the first place. We train scientists from these countries back in the US, and we help them set up small businesses themselves in these countries. So another way in which it's possible to promote peace, to get people talking to one another, and ultimately, once you get to a point where you can talk to someone and you can have common language, you can have dialogue, the chances that you're then going to want to go and talk them in some way become very much less. So dialogue is a very good thing, talking to people is a very good thing. It really is a wonderful way to make sure that peace ultimately ends up as being the norm rather than violence. Perhaps before I open this up to any sort of discussion, I should apologize on behalf of the US, which at the moment is not a particularly good emissary for peace. I think what's been going on in the US recently is actually pretty appalling, but that's my own personal view. Anyway, I will be happy to take any questions, enter into any discussion. Fire away.
How do you feel as a scientist about the money being spent on most of the research businesses?
What sort of research? You mean within companies or within company research? Well, of course, what happens inside a company is that many companies are doing research in order to try to improve products and to make more money as a company. That research can be good, it can be useful. Usually the way in which a company will sort of try to own what comes out of that research is to file intellectual property, file for a patent, and try to own the technology in some way. That's okay, because then at least it gets published, and after 20 years is out in the public domain and anybody can then use it. Some companies just treat it as a trade secret and don't tell anybody what they've done. And that always seems to me a bit of a waste. It's not something that we do at New England Biolabs. So all of the research that we do at New England Biolabs, everybody who works for us is expected to publish the results of their work. And anything that we think is commercially valuable, we will in fact file a patent on, but we will also publish it in the regular scientific literature. Does that answer your question? Yeah.
How do you feel with science?
How is science being misused? Well, I think the problem is that whatever one has, as soon as you make any kind of scientific discovery, there's always the possibility that it will be misused in some way. Probably the greatest example of that was, of course, the Manhattan Project, the development of atomic weapons, the development of hydrogen bombs, and so on. And I think it's just a rather sad reflection on the societies in which we live, that there are people who feel that this kind of behavior is appropriate. But in general, I think it's not the scientists who are responsible for this. The scientists make these things possible, but they almost never are in a position where they actually have the power to make a decision and say, we're going to push the research this way, or we're going to push the research that way. And it's actually quite difficult to think of things that become discovered that it's not possible to use either for good or for bad. Some things it's much easier to use for good, but unfortunately we have elements in our society which always will use things for bad if they're able to. The part of the job of societies is to make sure that the people who would use things in an evil way are sort of kept in check, and we try to prevent them from doing that as much as possible. Yes. Can you speak?
We're really honored today to have your time. I would like to ask your opinion as a member of the international community. Do you have any suggestions for students who are interested in pursuing research?
Okay, well, I'll ignore the first bit, which was just too flattering. But as for suggestions of things to do, I think, fortunately, we're in an age where science is really making wonderful leaps forward, but especially biology. So, if you're interested in research or interested in making discoveries, you always want to be going someplace that no one has been before. Now, if you're a physicist, it's actually quite difficult these days to find new territory. And one of the reasons is that in physics, one of the goals is to get to the very small and really try to understand what are the very foundations of atoms and these funny particles called quarks that make up atoms and so on. And in order to see inside an atom, you really have to smash them. You need unbelievable amounts of energy and have things collide so that you break them apart so you can see what all the fundamentals are. And it's getting increasingly difficult to do that in physics. We just can't afford to make the machines that are necessary to do that. Now in biology, on the other hand, we're in this wonderful phase at the moment where there is an incredible amount of stuff that we don't know. One of the things that's happened over the last few years, I would say since about 1995, when we first determined the complete DNA sequence for a bacterial genome. Prior to that, If you'd ask any biologist, how much we knew about a typical organism, well, they would have told you, well, we know quite a lot. You know, there's this organism E. coli, some of you may have heard of, this sort of thing we use in the lab. There must have been millions upon millions of man-hours of work have gone into studying E. coli. Well, when we determined the sequence of its genome, we discovered that half of the genes that were present were brand new. We didn't know about them. And yet we've been spending huge amounts of effort to try to discover them using more traditional techniques. So what's happened since then is that the more we look into organisms, the more we discover, well, we just don't know what is going on. Most bacteria, for instance, have never been cultivated. You know, if I were to go and look in any one of your mouths at the moment, about 1 in 10 of all the bacteria living there are ones that we can honestly say we know a little bit about. 9 out of 10, we've never grown them, we don't know what they are, we don't know what they do. And your body is absolutely crawling with bacteria, both inside and out, that we know nothing about. And most of them we can't even grow in the lab. And the few that we can grow in the lab typically don't behave the same way in the lab as they do in your body. So there's tremendous knowledge just waiting to be grabbed. So, you know, if you have in mind one day to win a Nobel Prize, work in an area where people don't know anything, because there you're guaranteed to make discoveries. It's sort of, you know, like walking in the rainforest. If no one has ever been there before, good chance you'll make a few discoveries. So biology is really very good at the moment. And if you want to do biology, one of the best trainings that you can take is either to do chemistry or to do physics first. Both of those are hard sciences. They teach you how to reason logically. They are just wonderful training, and you can learn biology on the job. I was never trained in biology. I was trained completely in chemistry. All the biology I know I picked up on the job. Easy to pick up biology on the job. Much more difficult to pick up chemistry and physics. Okay, so I'll take you first, 1, 2, 3, and then we'll come on to you afterwards, okay?
What are your views on the ethical issues that arise from research such as cloning and DNA?
You want to talk about ethics? Well, you know, here's an hour gone already. Can we stick with one thing? Let's talk about cloning, for instance. Okay, so there are many aspects of cloning. One thing that I think is on a lot of people's minds is the idea of embryonic stem cells. Let us say that we could isolate embryonic stem cells from humans. There are many things that one can do with embryonic stem cells, but of course one of the things you can do is to make new people, in principle. We're fortunately a long, long way from being able to do that. We can't even do that very well in mice or rats or any other kind of organism. But if we could, let us say that we were in a position we could grow these cells and make people. Should we make them? Well, let's look at it from sort of two extremes. One extreme says, well, wouldn't it be wonderful to be able to grow a whole army of people, you know, all of them bred in such a way that they were completely fearless. Wherever I sent them, they would go. They'd go to the front lines, no problems. We could make so many of them, you know, we could just generate more if the first band got killed. That's actually not a very good, efficient way to make soldiers, you know, because typically you've got to keep them going for about 18 years before you're ready to put them out into the front lines and so on. So I think those kinds of scenarios don't make a lot of sense. Another extreme, though, is to say, well, what about couples who can't have children? We have a couple, the father perhaps is perfectly able to make the child, but the mother is not, or vice versa. Why not allow that couple to clone cells from one of them and use that, grow a baby, and make a child in that way? Not a lot different from in vitro fertilization, which we think is perfectly okay at the moment. We have no problems with all kinds of sort of abnormal, I shouldn't say abnormal, but non-normal, non-regular ways of making babies. We help infertile couples in large amounts of ways. We inject hormones, sometimes leading to multiple births. You do in vitro sterilization. Why not allow them to clone something from either the father or the mother? That seems to me to be on the edge, ethically, of what might be okay, what might be not. But another use of stem cells, and one that I think is a great shame that in the West there's a lot of antipathy towards at the moment, is that you could use stem cells in order to grow new organs. But let us say you had a kidney failure and you wanted to get a kidney. Instead of transplanting the kidney from a pig or from a donor or from someone else, what if I could take an embryonic stem cell and grow a brand new kidney that would be exactly identical with the kidney that you normally have in your body? Would that be okay? That seems to me pretty good. We're perfectly happy to do skin grafts and have new skin that was growing on your thigh, grow on your face if you got scarred in an accident. So why not use an embryonic stem cell and grow new organs if they're needed? And in principle, I think many organs that go wrong, one should be able to repair in this way. This is a form of cloning. So there are many aspects to this whole conversation on cloning, but ultimately the best way to do transplantation and repair organs and to bring health to people who have been suffering poor health. I think embryonic stem cell research is a very good way to go forward. I think it's a shame that in the US we have George Bush and the Republicans, and in particular the Christian right, who are busy trying to stop this. And in Europe, they have a slightly more lenient attitude towards it. But I think there's a lot of religious mumbo-jumbo that is getting in the way of really doing good medicine. I think here's a wonderful opportunity, actually, for doctors and researchers in some of the developing countries really to take a giant step forward and maybe do something that would be really great for medicine that is not being done properly in the West at the moment. Okay?
For a question, what are your views on sort of the harvesting of organisms or such as horseshoe crabs in scientific research or even embryos in stem cell research? What are your views on sort of the termination of the life of these organisms?
Okay, so I think there's a difference between humans and horseshoe crabs. Horseshoe crabs are an endangered species at the moment. There are plenty of people around who actually like to make soup from them, not just for research, they actually like to eat them. In fact, my wife's grandmother grew up on Long Island, and there is a very nice beach just next to her house that horseshoe crabs like to come on a regular basis. She used to make horseshoe crab soup all the time. Of course, now you're not allowed to do that because this is an endangered species, and in the US at least, you're not allowed to take them at all. The horseshoe crabs again are a good example. You can grow them in the lab, so you can actually take a few, farm them, have them reproduce, and so on. So there are usually ways around some of these kinds of things. As far as embryos, you're talking about the whole abortion issue, is that what's on your mind? How far do you want to go with this? I mean, personally, I'm in favor of choice. I think basically if a woman becomes pregnant, it's really up to her whether she wants to carry through with that pregnancy or not. I don't think it's something that the state should intervene in. I think this is something that really is very much up to the individuals who are involved to choose. I wouldn't want some government telling me that my wife could or could not have a baby.
As humans naturally curious, in your opinion, do you think we should restrict our quest for knowledge if there's a chance what we discover could prove more harmful than beneficial?
Well, so the question is, when you're looking for knowledge, if you know ahead of time that that knowledge is going to be bad, should you therefore not go looking for it? I'm not sure that I know ahead of time that any knowledge could be bad. Can you think of something, a good example? Okay, so you use the nuclear bomb as an example, but in fact, nuclear weapons, when the key discoveries that allowed that all to be possible were made during the course of trying to understand the atom and what the atom looked like, and it was realized that if you could break them up, then they produced huge amounts of energy. And the first thing that the scientists thought about at the time was not that we could make bombs with these. The first thought was, here is a great source of energy. And in fact, we now have a nuclear power energy that is made from splitting the atom, that is only there for peaceful use. That had nothing to do with bombs. The idea that you could make a bomb with it only came much later when people like Leo Szilard and Einstein and some of the other physicists realized that the release of this energy could also be used for bombs rather than for peaceful purposes. But in fact, today, the peaceful uses of nuclear energy way outweigh their use for making bombs. And I think we could have an argument about what to do about nuclear bombs. We could have a useful discussion there. It seems to me that there are some really interesting ethical dilemmas associated with nuclear bombs. At the moment, the US seems to think it's okay if they and a few friends have them and nobody else should. How ethically you can make that decision that it's okay for the US but not okay for Thailand or not okay for anybody else, I don't understand how you can make that argument. As far as I'm concerned, it's unethical for anybody to have nuclear weapons. Yeah?
What are your views on scientists creating new drugs which are very effective on diseases and then putting it on the market and shooting the price up and turn the whole process of it as being a money-making scheme rather than something which will help the people?
So basically what you're saying is, should we have a pharmaceutical industry? Right, so, obviously one would like to bring drugs to market because people who get sick usually think that drugs are a good thing. Should there a company that makes them be allowed to make a profit? I think if you're operating in a system where you have private enterprise, where it's been private money that's gone into the development, there is nothing wrong inherently with making money. Should the extent of money that you make be limited in some way? I think that's probably something that governments really have to decide to what extent they want to try to regulate that. In the West, the argument has always been that one should not, as a government, really try to regulate private industry more than is necessary. If you're a Republican in the US, then you should have no regulation at all, and the drug companies should be allowed to make as much as possible. I think where I have a real problem is that when one then moves to countries that really cannot afford the drugs, what should be done? Should they be allowed to be made independently of the company that owns the patent and so on? I think the answer is probably yes, that there should be much better ways that we distribute drugs. And if you look at what's happening in Africa with AIDS drugs at the moment, there is slowly coming some realization that drugs should be made available to people at much less price. But the thing is, you can't give all of these away. If it costs you $500 million in order to actually do all of the research that's necessary to develop a drug, and that money has to come from somewhere at some point. Otherwise, there will be no drugs in the future. So there does need to be some money going into the drug companies if they're going to continue to produce drugs. What's very difficult, of course, is to know what is the right price, what is the right rate of return. And unfortunately, this is where the free markets have come in, at least in the West, in determining the price. The companies are going to get away with as much as they possibly can. But I think there are some real ethical questions here that are not easy to deal with. They're not as straightforward as one would like to think about just when you first look at them. They can be quite tricky to deal with. I think there's also another issue that is even more complex, and that relates to the fact that for much of the work I do, much of the work that many of my fellow scientists do in the US, we're working on diseases, we do work that has implication on disease that ultimately is going to drive up the cost of treating these diseases. So a lot of what we're doing is actually basic research that is going to make it very difficult for a lot of people ever to be able to afford the cures that we can provide. Should we therefore not be doing this work? Another question? I'd be actually interested in some comments here. I mean, rather than just asking me questions, maybe I should ask you questions.
It's a personal one. I just want to know what led you to want to work with DNA.
So, why did I get interested in what I got interested in? I have to go back to the time when I was a student in chemistry. I was a PhD student. What I was asked to do for my PhD, I was given a piece of wood that had come from the Brazilian jungle. My PhD thesis was to find out what was in this piece of wood. Well, it turned out that the wood had been reasonably carefully chosen because it had in it some natural products that the lab I was working in were quite interested in. And I had a very good Japanese postdoc who taught me everything I could ever wish to know about chemistry, how to do chemical research, and sort of why I was doing the experiments I did. And as a result, after a year, I had all the results I needed for my PhD. But in England, you have to spend 3 years doing a PhD. So what I did was I went off to the library and started reading stuff, and I picked up a book called The Thread of Life by a man called John Kendrick. He himself was a Nobel Prize winner. He was a crystallographer. He was one of the very first people to get a crystal structure, in his case for myoglobin. But he described in this book the history of molecular biology, which really got started at the Medical Research Council lab in Cambridge, following work, sort of thinking that had taken place in the US and Europe, and Paris, London, and so on. But he described the start of molecular biology, which really was the quest to understand what were the bases of life, how DNA was the basis, contained all the storage information, RNA was the message that translated that and moved that information onto the ribosome, and then how it all coded the proteins and so on. And it was the most incredible story. I mean, just a wonderful story, how you could start with DNA and ultimately, just on the basis of, say, the complete DNA sequence of the human genome, we should be able to understand how humans work. And so for me, I was absolutely hooked. At the time I read that book, I wanted to become a molecular biologist. And I would encourage all of you, actually, if you ever think that there's something that you might be interested in, that's a little off field, a little off base, not the sort of thing you're doing at the moment, go find a good book. Talk, read, but see if you can't find a biography of some scientist or an artist or a musician, whatever it is you think you're really interested in. Just go read some of their biographies and get a flavor for what's going on. Because sometimes you too, like me, will just get so captivated by what you read that you know this is what you want to do for the rest of your life. It probably took me, I don't know, half a day to read this book. And I spent the rest of my life following through on it, so to speak. So a good book, there's nothing beats a good book. Yep.
Just wondering what's the other part of your business with commercial, sort of business side of your organization, and what your function is, what business is it?
Okay, so you ask about the business that we're in. The business that we're in is to make reagents for research, and it really arose from work that I was doing at Cold Spring Harbor Laboratory that your headmaster mentioned in the introduction. There are these enzymes called restriction enzymes which recognize specific sequences in DNA and allow you to cut the DNA into very specific pieces. And when I first went to Cold Spring Harbor in 1972, there were about 5 or 6 of these enzymes had been discovered. And I immediately started to make these enzymes for myself, but then we started looking in other organisms, and we found there were hundreds of these things. And so it was clear these were going to be unbelievably good reagents in order to study DNA. In fact, without these restriction enzymes, there would be no biotechnology industry today. I mean, these are just the workhorses of this entire industry. And so I was fortunate that my lab found the first 50, 60 of these things, and I realized you could probably make money selling them to other researchers because everyone was coming to my lab in order to get a sample of these enzymes that we had. And so I talked to Jim Watson of Watson and Crick, who discovered the helix. He was the director of the lab at Cold Spring Harbor, and suggested to him that we should set up a little company and use the profits to help support the research at Cold Spring Harbor Lab. Well, in his wisdom, he said that you couldn't possibly make any money doing anything like that and didn't want to have anything to do with it. And eventually I found somebody else who had the same idea up in Boston, a man called Don Cohn, and he had started this company that we now call New England Biolabs. And so I took my idea to him, we talked a little, I became his chief consultant, and then he grew the business to where we are today. So pretty much all of our business is based upon selling reagents to the research community. Probably half of our business is still restriction enzymes, the other half are different kinds of reagents that we sell. So we support research by selling reagents to the researchers who are doing it, whether they're in industry or whether they're in academic life.
I believe you did some research on SV40 DNA, and why did you exactly abandon that research after you worked on it for so long?
Okay, so you talk about SV40 DNA. Actually didn't do a lot of work on SV40. SV40 is a small simian virus. It's one of the smallest animal viruses known, and when I first went to Cold Spring Harbor Lab, I was actually hired to determine the complete sequence of SV40, but as soon as I got there, I realized there were 2 other groups who were essentially doing the same thing, and since I, on the whole, don't like to compete all that much, I decided I wasn't going to sequence SV40. We did a little bit of work with it, but not a lot. Mainly what we did was work with adenovirus. And adenovirus is a larger virus. It's about 10 times the size of SV40. It's also a human virus, not a simian virus. And so that was nice. And so most of the work was done on adenovirus. And of course, as a result of that, I ended up doing the work that led to the Nobel Prize. Having made that initial discovery, the next steps that one needed to do to sort of capitalize on that were to do either experiments in which I had no personal expertise, or the experiments we tried in which I did have expertise, we actually got scooped by another group who went ahead and did something a lot better than we were able to do. And so I just moved on and ended up doing a lot of different kinds of stuff. So we sequenced the genome of adenovirus and then developed a lot of computational work. Most of what I do now is essentially computational biology. So I use computers to look at DNA sequences and try to find interesting things. I tend not to do the same thing all the time. I have one or two projects going, like in the restriction enzyme field. I continue to have some projects going there, but I like to go off and do new things all the time. And that's good because, you often make lots of discoveries as soon as you move from whatever you know about into something you don't know about. One of the things, especially when you get to someone like me, if I go into a field field, well, let's say I'm working in my field, if I start asking questions that everybody thinks are stupid, and they like to laugh at me and tell me that it's stupid, but if I go into another field that I don't know, then you can ask all sorts of stupid questions, and everyone will say, oh, well, it's okay, he's not in the field, so he doesn't know that we know this already. And usually it's only by asking these stupid questions that you actually find out things that are new. One of the things you have to be very careful of, I think, in school, but also very much so in research, is that your teachers think they already know all this stuff they're teaching you. And workers in the research field think they know all of this stuff already. And they very rarely question some of the very basic things that are going on. And often, the only way you really make discoveries is by questioning some of the very basic things. So, if a teacher tells you, well, this is the way it is, and we know all of this, ask them why, ask them how they know. Because sometimes it turns out they actually don't know. And the things that they're trying to tell you are, in fact, incorrect. Always good to ask questions. And on that note, I see we've run out of questions. Okay, well, maybe before we pack up, let me tell you a little story. So, 2 years ago, I have a son who is now 17. And 2 years ago, I was asked to speak, give a little address at the graduation ceremony at his school. And so I started giving, well, it was funny, when I told my son that I was going to do this, he said, his immediate reaction was, well, you didn't say yes, did you? So I had to confess that unfortunately, yes, I had. And he said, well, whatever you do, make it brief. Don't talk for a long time. Because obviously he was scared I was going to embarrass him. So I gave the talk, I talked about fireworks and so on. As soon as I said I thought all these kids should be making as many fireworks as possible, the headmaster leapt up and said, no, this isn't official school policy, I want you all to know. But I finished by telling the following story, which I hope perhaps you'll get a kick out of. Whenever you go to school, you always find out there are things you're being taught that you really don't see any reason why you should be taught them. This is often especially true of foreign languages. So the story goes as follows. There was a small, very timid mouse that lived in a hole in the wall of the kitchen. And one day, this mouse was extremely hungry, and he knew that there was a nice piece of cheese just across the kitchen. And he put his head out of the hole and looked around and saw a big shadow. And he thought, gosh, it's the cat. I'd better not go, and he leapt back into the little mouse hole. Well, a little while later, his tummy is rumbling, and he says, I've really got to go. I've got to go and get some cheese. He puts his snout out again. Sure enough, the shadow is still there. And so he retreats back into the hole. The third time he does it, shadow is there, and he hears, woof! He says, oh my God, it's the dog, and he rushes out to get the cheese. And the cat grabs the mouse, and he set up for his supper. And the moral of the story is that you never know when a second language is going to be useful. Thank you.
Thank you, Dr. Roberts. On behalf of the students and the staff of New International School of Thailand, we'd like to thank you for your perspective on the science behind business and the business of science and the effect of the use and misuse of science on our society and individuals. It's a topic we haven't had before. Your comments were very enlightening. The questions from the students were excellent, and your responses were very detailed, and it gives a different perspective of life. We're all scientists in one way. We all study science as part of the IB, and we've all got science affecting our lives. So thank you very much. I'd like to call on Meetha to present to you a small token of appreciation for coming to be with us today, and maybe Meetha might want to say a few words.
We all want to thank you for giving us your time and sharing your knowledge with us. We all appreciate it, and thank you so much.
And thank you to the audience for staying well back after school today. Very much appreciate your time. I'm sure there'll be thoughts that you'll take away and reflect upon, and no doubt use in science and particularly TOK in future lectures. Okay, it's over. Thanks very much.
One minute.